Hi guys, I hope you're good since last video. We have seen ways to control where we want our workload to be dispatched by the scheduler using labels, selectors of different types and affinities, but there is a missing piece which works in conjunction with those taints and tolerations. The final answer, you taint nodes and you put tolerations on pods. We are going to see how taints and tolerations work, what is required, and what is lazy. Open your terminal if you want to follow along. It will be fun and chill as usual, and human-made, so we will fight if there is any errors in the way. I've left a link in the bio for the students who want to learn AI by doing, beginner devs who want to think at a service they could offer, or business owners who want to use AI for themselves. It is free. There is a guide PDF to download on the video. Link is in the pinned comment or video description. Get it now from our hub, Shaker Houses. Also, please like and subscribe. Thank you for your support. Let's get started. NoSchedule. So for the time being, this might not be meaningful to you, but at the end of the video you will be mastering that and understanding everything. We still have a cluster having 3 nodes, 1 controller and 2 worker nodes. Workload can be deployed into the controller node. So this is permitted in my little cluster so that I can run everything everywhere. Here I'm just showing you that there are no pods and no taints. So there's no pods deployed. We describe the controller node, we describe the node 1, and after I'm going to do the node 2. So it's part of the configurations. You see here taint, it says none. So that's how it comes by default. By default also, when I started my cluster, the controller node had a taint, so that no workload could be scheduled there, but I got rid of it. Okay, so here taint none. So we're starting with a fresh cluster. No taints. We have our 3 nodes available for workload deployment. So here I'm going to create a boilerplate, a deployment. We're going to start slowly, just by seeing how it behaves. And after we're going to incrementally add some taints and different options and see how the cluster reacts to it, how the workload, how the scheduler dispatch those pods across the 3 nodes. So here we create a deployment, Nginx omotesando. We still use those Tokyo neighbors, image Nginx replicas 3, and we're going to output in a YAML file that I'm going to call Nginx omotesando YAML. Just let me change the name. So from Nginx omotesando YAML, I'm just going to move it in this folder. Maybe it's better, so that you can see the folder is called node taint pod toleration. So at the end of the video, this will be in your mind and you won't forget it. Makes life easy. So I'm going to edit this deployment. I can get rid of some of the fields that we don't need. But here I'm just going to put a little label on the top to say that Nginx omotesando, it's a deployment. This one I can get rid of it. Strategy, I can get rid of the resources, the status. And maybe here, let's customize the app label. So it's called the Nginx omotesando. I'm just going to change it to Nginx Tokyo Center. So we got our deployment with 3 replicas. We're going to just write this file and open the terminal. So let's open the terminal now. We're going to apply this deployment to the cluster. Maybe before applying, I'm going to maybe Taint not too. I just get rid of a tint that I have because I did some tests before running this video. So I'm just going to get rid of it. Now I can apply it to the cluster. We get the pods. Okay, each node have 1 pod deployed. So the scheduler did a good job. Controller, node 1 and node 2. Now we're going to taint one of those nodes, the node 2. So k-taint node 2. We're going to call here the key Shibuya, the value Mangakisa caret, and the effect NoExecute. Okay, node 2, Shibuya Mangakisa caret, and NoExecute. So this will be active on the node 2. Okay, so let's see what's going to happen. Let's get the pods. They're still running. I mean, now they're running, but they didn't. Nothing has changed. The state is the same. Okay, now I taint it. So before I used Ctrl+C just to show you that the state is the same. Now I put the taint in, and you see now one of the pods have been deleted. This one is the same. This one is the same. Node 1 and controller, but the one which was deployed on the node 2 here is not there anymore because of the taint. So the pod is not matching this taint. NoExecute effect is going to evict this pod on the replica set of the deployment. It's going to redeploy to get this high availability. So we get the node 1 chosen by the scheduler. Now let me do the same with the node 1. I'm going to taint the node 1 with the same tint with the effect NoExecute, which is going to normally evict those pods, and that's what's happened. And we get the full deployment, those 3 replicas, all in the controller node. They don't have any more space to go to. They're not allowed in those nodes because of the tint that you have put, the key and the value, and also the effect. We will see some other effects and how the cluster is going to be behaving in terms of, the scheduler is going to behave. So let me just get rid of the tint on node 1. Okay, you just put the key and you put a minus after that. That's how you get rid of it. I'm going to delete one of the pods. So let's delete this one here, for example. Just to get the scheduler redeploying this pod with another ID at the end. So the 5 last characters. And yes, now the node 1 is free to receive workload because we got rid of the tint, has been untainted node 1. That's how we get this deployed on node 1 now. Okay, let me get rid of the tint on the node 2. Do the same process with the node 2 just to recover back the behavior of our cluster. I'm just going to grab the name of one of those pods which are still living in the control a node just to get a balanced workload across the nodes. And yes, node 2 is available. Again, you see container creating, and it's going to be running there. So this is the introduction to node Taint with the effect NoExecute. Okay, NoExecute, which is going to evict the pod, any existing pod which is not matching that Taint and effect will be evicted, and after the replica set is going to take care of it to redeploy the pod somewhere else. If it was a standalone pod, so a pod without any replica set being implemented, it's just going to disappear and you're going to lose it. So it's important to know those kind of behaviors. So let's keep going. You can pause the video and check the YAML files, check the comments, run those on your terminal. So here I'm just going to delete this deployment. We get the pods, there's no pods deployed anymore. We got rid of the deployment. And let me create a new boilerplate as we're going to go to the next example, which is NoExecute tolerated. So here I'm going to try to create two different YAML files, and you'll see there will be a little there'll be something different between those two, but it will be expressed in the naming of the file. So we run the pod, we just create a boilerplate, we call it nginx noexecute.yaml, noexecute tolerated .yaml. Okay, so we got our first boilerplate. So I'm just going to do the same here, but we're going to add to the name with seconds. At the moment it doesn't mean anything, but when we're going to start putting those options into the YAML file, and after deploying it and seeing the behavior of it, you'll understand what's going on. Okay, so we got those two, NoExecute tolerated and NoExecute tolerated with seconds. Let me just edit one of those. Probably we'll be able to just copy and paste it there and just change it a little bit. But for the moment, let's work on this one, which is the nginx noexecute tolerated. So noexecute will be the effect. So we got node tainted, so the taint on the nodes. So I'll be repeating that a lot. And we get toleration on the pods. Okay, so here I'm just getting rid of the different fields that we don't need. I change the label for app nginx no toleration seconds. So here there is no toleration seconds, while in the other one there will be toleration seconds. And the effect that we're working on, focusing on, it's the NoExecute effect. Let me put it as a name. Nginx no toleration seconds, and the label nginx tolerate noexecute. So here what we are going to do, we are going to add a toleration on this pod, and we're trying to make this toleration match the taint that we are gonna put in the node. That's how the pod will be able to be scheduled by the scheduler controller in that node. We might use node selector to force it to go in a certain node, so it can conflict with the taint that we're going to put in that node, and we're going to see what's going to happen. Okay, so here we are in the spec, container, the image is Nginx, the name, it's Nginx tolerate NoExecute. What I'm going to do here, instead of using node selectors, let's play with what we've learned before and use affinity, which is more fine-grained. So affinity, node affinity. So I have to be careful here with the indentation. Node selector terms, we match expressions. So I'll be fixing those indentations. I feel like node selector terms. Let's see, we'll see when we run it. So we have match expressions. After here, I just so whatever I'm writing here is not yet existing. So I will need to put those labels on the nodes, and also to put those tints. So here we're going to use a key. The key is Junko. The operator is exists. So this key has to exist as a label on the node. Okay, that's the affinity that you have chosen for that. So we're telling here to the scheduler, I want this pod to be scheduled in a node having the key Junko in its label. That's what we're saying here. But that node will create a tint for that node. So we need here to have a toleration. Otherwise the pod won't be allowed to be scheduled there, even if we have an affinity, a node affinity defined in the pod. So here the toleration, the key will be Shibuya, operator. So here let me just to show you different ways of writing it. So we can write it this way also. So this is more like a dictionary. In the dictionary there are some lists or strings. We will see when we run it. So here the toleration has a key Shibuya, the operator, we want it to be equal. The values, we just have one value is present. So we want key Shibuya value present. The effect, it's NoExecute, because that's the effect in which we're focusing at the moment. The effect that evicts pods from a node if it's not matching. But here we're matching it. Okay, the value is present and the effect NoExecute. And the node affinity, match the expression with a key Junko. So we need to have tint and labels on the nodes. Okay, I'm just gonna cut this file. Okay, so that's the recap of what we've done for the first one. So I might just copy it, as I said. Okay, let's yank it. And we might open the other file and just change the content on the different options, so that we don't need to retype everything. Let me go down there. Okay, we're gonna paste it, and I'm just gonna DD everything here. Just DD. I'm gonna delete everything. Okay, so this one is the file called Nginx NoExecute, tolerated with seconds. So here there will be an extra option that we are going to add, which is the seconds. So some time constraint. Okay, plus toleration seconds. So let's just change the different namings. So here the name is Nginx with toleration seconds. The label NoExecute. Should I change it? Let's keep going. And here we are going to add an extra option. Toleration seconds. So we need some time to be able to see the effect of it. So I'm going to put 45 seconds. I can put less, I can put more. Let's go for 45. So we have a key, same as in the other one, Shibuya. We have the operator equal. So we want the value to be equal to present. The effect is a NoSchedule, NoExecute. NoExecute effect, that's what we're focusing on. And we have the toleration seconds set to 45 seconds. Okay, so hope that you had the time to write everything before running it. We can check those once again. So that's the last one with the toleration seconds. And the other one without any toleration seconds. Okay, so 45 seconds up there, and down there's no toleration seconds option. So we need to tint those nodes. I'm going to choose the node 2, Creditizens.net. Maybe I put tint, but I will change it to labels, because it's the Junko label here that we're trying to match. After the value can be anything, because we just said in the node affinity that we want the Junko key to exist. So here we just say Junko equal happy. Okay. So let me write it the correct way. Key label, node 2 Creditizens, Junko equal happy. Okay, so this is the label of this node. So we have done the label of the node. Now we can do the tint. So we said that the tint has to be with a key Shibuya and the value present. Before putting any tint, let me apply the NoExecute tolerated. Okay, we got an error. Pod spec container. Yes, can you spot the error? Okay, I can see it at the moment. Let's just use nano to open this file and fix it. Okay, you come here. You need a little dash for name. And the image has to be indented at the name level, not at the dash level. Like that. I'm just going to put it under. Alright, so let's put here image Nginx. Okay, now we're good. So let me do the same for the other one, because I did just a copy and paste. So the errors are going to be copied and pasted also. So now let's put here image Nginx. Okay, so my terminal is bugging a bit. I might need to clear this page. Because you see, we got an error here again. Spec toleration values. So let me reapply it here so you can see it. So we have here the field toleration 0 values. Let's go down. Because I've forgotten something very important here. So you remember when we've done the affinities, we had the preferred or the required. So this is a strict one, is required during scheduling. So we want to push the scheduler to for sure choose the node which has this key Junko. And for that, you need to use required during scheduling, ignored during execution. Okay, we just push all the indents. Now we're good. So it's good to face some different errors so that we can see how to fix those. For sure, the other one needs to be fixed as well. So let's fix the other YAML file with required during scheduling, ignored. This is scheduling, ignored during execution. Okay. Let's try again and see if there's any other error to fight. Otherwise we get it deployed. And if not, we're just gonna go yes. Pod version v1, strict decoding error, flag. Okay, so we might need here to use string. So this is value. Let's do value. And now we got the error telling us that we need to have everything between quotes. Okay, because we choose to write it this way, so you need to use the quotes. So this is not a list, it's value. We put the quotes, and we're just gonna do the same for the other ones. So the terminal will stop crying. We go back in. Let's do this for Shibuya, the key, the operator equal, value is done, and we do the NoExecute as well. So we do the same in the other file, and after that, you've seen all the kind of different errors that you might get with those files. This is fine, value, effect, NoExecute, and this is the toleration has to be 45. We can't put any quotes on the number. Okay, let's go in the cluster. This one has been deployed, and the second one as well. Get pods. Just want to see where is it scheduled on node 2. Okay, all good. So it's following the requirement in the affinity. So I just used labels. I didn't use yet. I'm just going to show you the nodes. You see the labels. So for the column Junko, we get it happy on node 2. So that's why we get it on node 2. So the YAML file has a toleration, but the node doesn't have any tent. So it's fine. It can go on node 2. Let's see those files again. Toleration. Okay, on this toleration. So the toleration doesn't have any effect yet. It doesn't need to match anything. It's more on the node side. When there is a tent, at this time, the pod scheduling can be blocked, but not the other way around. So let's check that, if it is true. Let's tint now the node. So key, so I'm using K because I use an alias, but you use kubectl. Tint node 2, Creditizens net, Shibuya equal present, key value, and the effect NoExecute. Okay, get pods or wide. Okay, so for the moment, those two are still in the node 2. I'm just watching what's going to happen when I'm going to apply this tint. I didn't apply it yet. Now I've applied it. Node 2 has been tinted. All good. So we said if the pods tolerations are matching the node tint, they're going to stay on the node. But this one has a toleration second, which is a bit different. And we're going to see what's going to happen. So we gave it 45 seconds. So we're going to wait together just to see what's the behavior of the Kubernetes cluster. Oh, terminating. And now it's gone. So the toleration is matching the node tent, but because it has the option toleration seconds, is going to stay on that node alive only for a certain amount of time. The toleration seconds determined time seconds. Here was 45 seconds. And after that, the scheduler can schedule it in another node if it is a deployment, so if it is implementing a replica set. But here, it's not implementing any replica set, so it's a standalone pod, so it's a lost pod. It's just going to be evicted and disappear. So I can subscribe during the break. Again, but with a more relaxed rule. So I'm just going to delete the pod, which is still living in the node. Okay. Okay, the pod has been deleted. Okay, so this one, that's the one which doesn't have any toleration seconds. We're going to just taint node 1. Maybe let's label first. Let's show the labels for Junko. So for the moment, we just have node 2 with this label. So the node 2 had the Taint Shibuya. We're going to get rid of it. So there's no more Taint in the node 2. Just have that label living there. Just for the next example, we're trying to see how we're gonna prepare the cluster. And if we need a boilerplate, or if I'm just gonna copy and paste an existing pod that I'm just gonna modify. So let's copy this one here. Let me edit the next pod that we're gonna deploy, which is called Nginx NoSchedule, because before we did NoExecute effect, now we're gonna check on the NoSchedule effect. So this one is Nginx NoSchedule tolerated.yaml file. Okay, so Nginx NoSchedule tolerated.yaml. Okay, and that's a pod. We're going to work with pods. And the effect NoSchedule. So here I'm just going to change it for NoSchedule. For the name, we're going to call it Nginx NoSchedule. For the container, we're going to do the same. We can keep the key or the affinity. And here we put NoSchedule. Let's see if we need to change the operator or not, or the key. So the key I can put Harajuku, maybe you know about this neighbor, or maybe Ueno. We know it's not known by everyone, but it's a cheap place and nice. There's a big park there, and we're gonna put the value Narita because that's the first big station when you arrive from the airport. So here we have the key Ueno, the value Narita, the effect NoSchedule. So with this effect, how it's going to be behaving? We've seen that if the toleration is matched, when it's NoExecute, pods are not evicted from the node. They're evicted only if it doesn't match, if the toleration doesn't match, as we've seen with the first example at the beginning of the video, or if we have the option toleration seconds. At this time the pod is going to live on the node for a certain amount of time, and after that it's going to be evicted. With NoSchedule it's going to be a bit different. So here I'm just going to create another YAML file. I've copied this one here, and we're just going to modify the names and add some options. Okay. So here, what are we going to change? We're going to keep the affinity, the node affinity, with the key Junko. So NoSchedule tolerated 1, NoSchedule tolerated 2. Get pods. We just see where those are scheduled. They schedule on node 2. So this is following the strict rule of the affinity, node affinity. So we get those two here. Okay. They're both similar pods. So let's delete the second one. So now we have only one living on the node 2. So we have one living on the node 2. We have one not deployed, which is the same. Okay. This is how this YAML file looks like. We have a key, Ueno, a value, Narita, an effect NoSchedule. We're going to use that to taint the node, tainting the node 2 with a key Ueno, a value Narita, and an effect NoSchedule. Is the pod going to be evicted or not? What's the effect of it? Nothing. The pod is still running. Okay? The pod is running, but the pod is matching the effect. So let's describe this node 2, just to have a recap of what is in this configuration. So here we get the tint here field with Ueno, Narita, NoSchedule, the effect. So that's how node 2 looks like. Let's clear the page. So we're going to use one terminal to watch and see the effect of the pod scheduling, what's going to happen. And I'm going to apply the second YAML file, NoSchedule tolerated 2. container creating, and now it's running on the node 2. Why is it running on the node 2? Because it follows just a simple rule. The required node affinity, so it goes on node 2, it checks, and after it sees that the toleration is matching, so it's going to be scheduled. No issues for the moment. Okay, so we're back to the initial state. If you create the pod is not evicted. If you schedule the pod from outside, you get the pod deployed if it's matching the toleration. So we're going to delete again this pod. It's going to be terminated. Okay, we're back to our only one deployed, and I'm just going to be playing with that one now. Now let's play with the toleration and see what's going to happen. Let's add the same option that we had before. Toleration seconds. 45 seconds was a bit too much. Let's go for 15 seconds. Just the time to see what's going to happen. Invalid effect. NoExecute. So toleration seconds doesn't work with NoSchedule. It works only with NoExecute effect. Okay, so this is one example. Let's get rid of the toleration now. We get the affinity saying that only this node can receive this pod, because there's no other node with this label Junko. Okay, created, but it stays in a pending state. You see the status is pending because there is no matching toleration, so it's never going to be scheduled. Let's describe the pod and see what's going on. Zero node available. One node had untolerated Taint Ueno Narita. So it gives us here the key and value. So we get a lot of information here. As you can see, you can pause the video and read. It's a nice description. Failed scheduling because it's not matching the toleration, which is Ueno Narita for the key value. Let's clear this page. Let's delete this pod, this pending pod, so we don't need it, we just get rid of it. And now it's going to be terminating. Let's get back in the pod. I'm just using Nano. Okay, so when there's no toleration with no schedule, if it doesn't match, you won't be able also to schedule any pod on that node. So you taint nodes and you put toleration on pods. And here we're just going to use preferred NoSchedule. So this is the lazy version of it. Okay, so we have a strict rule, which is the affinity on key Junko, so it's going to go on node 2. There will be just one to select, while the, let's see, it's not matching. See? Try to apply, it says effect unsupported, preferred NoSchedule. Supported values are NoSchedule. Okay, here is because I did a typo. This is not. So let's get back in and get rid of those typo errors. So it's not preferred with double R. It's just prefer NoSchedule. Let me get rid of the D also. Yeah, I forgot the D. So here, prefer NoSchedule. So you see there are just 3 different effects. NoSchedule, prefer NoSchedule, and NoExecute. And here, we're just going to modify this and see what's going to happen in the cluster. Okay, it's in the pending state because it's not matching the toleration again. Toleration says effect NoSchedule, and we are using the effect prefer NoSchedule. As it doesn't match, it will stay in a pending state, as you can see here. So there is only one node that can be selected, is the node 2, because of the affinity, the strict rule. And here we just get failed scheduling. Okay, 0 nodes available, 1 node untolerated taint. We get the same message. Okay. So the message is very explanatory. It says that there is 2 nodes that didn't match the pod affinity. That means there is only 1 node where it can be deployed, but is not matching the toleration effect. So let me change the taint on the node. Ueno Narita. Let me write it the right way. Prefer NoSchedule. Okay, has been tainted. Let's describe just to see if the effect is has been applied. Okay, so now we have 2 of those. That's why it stays in a pending mode. You see, it's still pending, because we still have the NoSchedule effect. So let's just get rid of that. We can use edit mode for that. Just find here where are those effects, and we get rid this one here, and we get rid of it. So you see here NoSchedule Ueno Narita. I'm just trying to see how I can use here Vim inside Vim. This is a Vim editor, so I have to press Shift and Control at the same time to be in. So I got rid of it. I'm just going to save it. It's going to be updated, and now you see the pod is running. So now you understand that it has to match perfectly the tolerations and all of those tolerations. I mean the tent, all of those tents on the node. So you need to create the same tolerations on the pod, otherwise it's not going to be scheduled. Now it has been scheduled. It's not in pending mode anymore. And here is because there is only one node with that Junko label. If there were more nodes, it will be maybe able to go in another node without this tint. Okay. And now we have only one, which is good. That's what we wanted. Okay, so now you understand what's the behavior of the cluster. When you use Taint and Tolerations, we've seen different effects. NoExecute, we've seen also the effect NoSchedule, and the effect preferred NoSchedule. After you can get rid of the tint by just going with a minus after the key. And that's how you get rid of it. After we can just delete everything. With this last piece for workload scheduling management, you will get full control with labels, selectors, affinities. You will be able to have more control on what goes where and not get some random Kubernetes behavior surprises. I will try to use some of those concepts in future videos so that you can review those in a more natural way while adding a new concept on the top. We will see. We're good. Let's stop here. Hope that you like this video. Please like and subscribe and see you next time.